How do you find the circumference of a circle? Well, we get it by the formula 2 pi r. But how do you know what pi is? Early on, mathematicians came up with the method of exhaustion. By continuing to add polygons similar to the shape, it gets closer and closer to the area they are trying to find. Archimedes decided to use this method to estimate pi. He did this by adding the perimeter of a polygon inside a circle. Increasing the amount of sides gave him a more accurate approximation of pi. Around 250 BC, he was able to calculate up to a 96-sided polygon and found that pi had to be between these two values. This remarkable feat by Archimedes is similar to an integral. But what is an integral? Or better yet, where is it used? Let's start at the beginning. We all know the infamous tale of Newton discovering gravity and the laws of motion through an apple dropping on his head. But how does a seemingly innocent event cause the birth of what many people consider hell? He wanted to know the answer to a simple question. How fast was that apple moving? Except, it's not simple, and the reason why is because of gravity. You see, because of gravity, the speed at which the apple was falling changed as time changed. And so he created a new branch of math which he called the method of fluxions, which refers to the instantaneous rate of change at a given point. Calculus is the study of continuous change, and Newton's goals were the basis of differential calculus. Differentiation is all about finding the rate at which something is changing. And Newton wanted to learn all about movement, the speed of any object at any time, because he wanted to explain gravitation and how celestial bodies orbit one another. With this, he was finally able to answer his question on how fast the apple was falling at any point of the fall. It's important to note that Newton wasn't the only one who helped create calculus. In fact, many of our modern-day notations for calculus comes from another person. Even though Newton and Leibniz both independently created calculus around the same time, Newton thought the other merely copied off his work, which led to controversy. Now that you know all this, it's finally time to answer the question that started all this. What is an integral? Well, differential calculus is all about the rate of change. An integral and integral calculus is the counterpart. It is all about the accumulation of all those changes. Take a look at this in Minecraft. How far would the player travel in 5 seconds? We know that at max speed, the player's position is changing at a rate of 5.6 meters per second. And so we can solve this by taking the integral of the speed. Let's take it from 0 to 5, since we're starting at 0 seconds and we're going to be running for 5 seconds. We see that we should get 28 meters. Each block in Minecraft represents 1 meter, so we should see that the player runs 28 blocks. Each color segment is divided into 4 blocks, so we should see 7 color segments if Newton was right. And he was right. Calculus was used by Newton to both explain the speed at which objects were going and the distances traveled in order to explain gravitational forces. But that's not the only part of our world where calculus helps. Nothing ever truly stays the same. There will always be some sort of factors changing things. And in those places, calculus will always sneak its way in.
No! What are you doing? What are you doing? Why did you engage? Why did you engage?
Why did you just kill me? Why did you just kill me?
Why did you fight it?
Why did you not just kill me? Ah!
I couldn't just jump down. I would take fall damage.
Yes!